Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be on page 159. That is lesson 4.2. We're going to be talking about two variable linear equations. And what we're going to be talking about today is the idea of graphing lines. And I know we talked about this concept in Algebra 1, but I think it took a whole chapter in Algebra 1 to talk about what we're going to talk about in one lesson today. So, put your seatbelts on and get ready to listen fast because I'm going to be talking fast. The first thing that it talks about there on page 159 is it talks about the intercepts. If you look down here, I've got some different kind of like some hints as you're looking for the intercepts. What does the intercept mean? It's the place where it crosses the line. Remember, the x-intercept is where it crosses the x line. The y-intercept is where it crosses the y line. Okay, so how would I solve this? If I was looking for the x-intercept, I would substitute the y with 0 and solve. So in other words, you would just work the formula, work your equation with 0 in place of the y. Whatever you get for an answer, that's your x-intercept. You would do the same thing for your y. You just plug the 0 in for the x, go through the process, solve it, and you would get the y-intercept. Let's look at an example right here. So I have y equals 2x plus 8. So if I'm looking for the, let's start off with the x-intercept, okay? So if I want the x-intercept, remember I would put 0 in for the y. So I'd say 0 equals 2x plus 8. I would just solve this again, trying to get x by itself, trying to get it to say x equals or something equals x in this case. We'll move the 8 to the other side, so we'll get negative 8 over there. And then, so we'll get negative 8 equals 2x. Then we would divide both sides by 2. And we would come out with, that's going to cancel, and we would get x equals negative 4. So our x-intercept on this one is going to equal negative 4. And then what I would do is I would just start the process again, and instead of putting the 0 in for the y, I would put the 0 in for the x this time, and then I would get the y-intercept. All right, so if we put y equals 2 times 0 plus 8, that's going to be 0 plus 8, or y equals 8. So our x-intercept would be negative 4, and our y-intercept would be 8. Now, what does that do for us? Well, what that does for us is it allows us to graph that. So I'm not going to take the time to put up my graph paper. I'm just going to draw a really rough graph here. And so we would take the x-intercept of negative 4. And so remember, this is the x and this is the y. The up and down is the y. So we would go left 4 for negative 4, 2, 3, 4. And so we would graph a point there. I'll graph it in pink so you can see it. And then we would graph our y-intercept at 8. And so I would go up 8, 1, 2, 3, 4, 5, 6, 7, 8, somewhere up there. And I would put a point there. And then I would just draw my line through those two things. Okay? And that's how to graph by using intercepts. I think as far as, graphing goes, it's one of the easier ways to graph. But there are easier ways than that. I prefer slope-intercept, which is what we're going to talk about a little bit later. And then you can always graph by just plugging in random points and getting it that way. But the intercepts is a very quick way to develop a graph for your equation. All right, if you will, go ahead and look over on page number 161, page 161. And this is graphing with slope, So pretty easy steps, are just really two steps. Graph the point, then graph the slope. Okay, so if you're graphing with slope, usually they're going to give you a point. Sometimes they may give you 2 points. If they give you 2 points, remember how to find the slope. We talked about that in the last lesson. So you would go over in the last lesson and you would use the slope formula, find the slope, and then you would graph a point, and then you would graph your slope after you find it. But in this case, they give us 2 points. Let me real quick switch over to graphing paper, and we will do this one. Let me put a, well, I'll change the color of that line so you can see it a little bit better. All right. So our point is going to be at 0, -2. So we're going to put a point at 0 on the x, -2. So that's basically an intercept. That's a y-intercept right there. And now we're going to graph our slope. And remember, slope is always over 1 because we have an x, that's the rise, and then we have the run. We have the, or excuse me, the y point is the rise, and then the x point is the run. So we always have to have y over x, or rise over run. So what we're going to do here is we're going to rise -4. Well, go down -4. So 1, 2, 3, 4 down, and then we're going to go to the right 1 spot, and this is going to be our second point. And so there we go, and then we are ready to draw our line up through it. I didn't draw a very good line. I'll draw a straight line. So, all right, there we go. And then that would be our line based on the point. We put the point at 0, -2, and then we graph our slope. -4, that means we go 4 down, and then 1 means we go 1 to the right. Now, what would we do if that was positive slope? We would go up 4 instead of going down 4. Then the next thing down here we're going to talk about is the different forms of a line. And this is found, I think you're really going to like this. It's on page 162. They've got a really nice table there for you to look at. And you can, copy that down into your notes, or you can go and you can just study right from there. And but I've got it written on the board. So typically, I tell students anytime I'm writing it on the board, you should be writing it in your notes. The reason why I wrote it on the board is because it was important. If it was important, that means that you should probably write it down. You might say, well, I'm just going to look at it and study it. Well, that's okay. But when you write things, your brain remembers them better. So if you'll write this down, I think it will help you. This is standard form. And this is standard form of the line equation, of the linear equation. And the standard form of the linear equation is ax plus by equals c. Okay, one thing about standard form of a line is sometimes you will not have an x or a y. In other words, what if b equals 0? And so 0 times y equals 0. What happens if your y goes away? Well, what happens when you don't have a y is you end up with a vertical line. So again, if you're looking at that chart there in your book, it says that the horizontal line in standard form looks like y equals b. In other words, the x goes away, the x is equal to 0. And with the vertical line, the standard form looks like x equals a. In other words, the y term goes away, or the y equals 0. And what ends up happening is your line either is vertical, straight up and down, or your line is horizontal, side to side. And that happens because there is no x term or there is no y term. All right, the next thing is slope-intercept form, and this is in your book on page 163. 163, you probably recall this from last year in Algebra 1, but in slope-intercept form, we have y equals mx plus b. Y equals mx plus b. We have to remember some things about this, or else we're not going to know how to handle this. Remember, the m is our slope, and the b is our y-intercept. Okay, so our m is slope, and the b, and this could be positive or negative b. If it's positive b, then it would be up on the y. If it's negative b, it would be down on the y. Okay, but that b is our y-intercept. Some students sometimes ask, well, what is the x and the y? And the x and the y are just coordinate points. So if I had like a 3, 1, well, then that's the x and the y. All right, and so those are just points. But typically when you're using the slope-intercept form, you don't have your points. You only have the y-intercept and the slope. And you'll see when we start using that more and more, you'll see how that works out. The last one, the last form that I want to show you is the point-slope form. Point-slope form. And this is when they give you a point. And this is on page 164 in your book, page 164. The example that they give you says that the point is 3, 5. Okay, and then they tell you that the slope is 2/3. Remember, I just wrote m because m is slope. So what we're going to do now is we're going to take that and we're going to plug that in. So everywhere that you see an x1 and a y1 is where we're going to plug in the x and the y points. These are going to end up, what we get from point-slope form is we get slope-intercept form. And you'll see that when we plug these things in. So there's the x, and it goes way over here, sorry. And then here's the y, and it goes right here. And then the slope would go right there. So let's go ahead and plug it in and see what happens with this. Y minus 5 equals m, 2/3, times x minus 3. Now we would just solve it like we would solve any algebra problem, and we would go ahead and distribute, and we would get y minus 5 equals 2/3 x minus, and you can come over here and do this over here if you need to, times 3 over 1, so that's going to give us 6 over 3. Now you can reduce that if you want. That's probably going to help you if you reduce that right there. So we divide that out, we're going to get 2. So that'll be 2. And then we are going to add our 5 to both sides, and that's going to cancel, and we're going to get y equals 2/3 x plus 3. And now look what we have. We have y equals mx plus b. We have slope-intercept form. Y equals mx plus b. So in other words, what's our m? Our slope is 2/3. What did we get from putting it into that form? What did we accomplish? Well, we accomplished getting our b term. We accomplished getting our y-intercept. And that's important because now we can graph it. How would we graph that? Well, we would go ahead and put it on our graph, and we would graph that thing at 3 because that's our y-intercept. And so we'd graph it up here at 3, put a point, and then we would graph it using our slope. So we would rise 2, 1, 2, and then we would run 3, 1, 2, 3, and there would be our second point. And then you get your second point on there, and then you can draw your line. And I'll just draw a little, just a rough graph right there. And so that is graphing from point slope. Okay, so that's point slope form right there. All right, I know it's a little bit of a longer video, lots and lots of stuff packed in here, but I've got one more thing that I want to show you, and that is parallel and perpendicular lines. Parallel and perpendicular. Well, what does that mean? Before I show you kind of the definition or kind of how to work them out, what does it mean, first of all? Well, if we have a graph and I have a line here and a line here, those lines are called parallel. In other words, those lines will never touch each other. They will keep going into infinity and they will never touch each other. That's parallel. Well, what is perpendicular? Perpendicular means that the lines will cross at a T shape. Okay, so in other words, they form a 90-degree angle right there. All right, so that's what we're talking about. We're talking about parallel and perpendicular lines. Now, with parallel, you need to know that the slope is always going to be the same. The slope will be identical. Why is that? Because if we have two lines going like this, then they both have the same slope. So let's say that it's 3, 2. Well, this one would also have a 3, 2 slope. Now, their points might be different, but the slope is going to be the same. Now, what about perpendicular? The slope is the negative reciprocal. Sorry, tried to get the word reciprocal on there. There it is. The slope is the negative reciprocal. What does that mean? Well, reciprocal means to flip it. So if we had 2/3, what did I say? 3 over 2 was the slope. So if I had 3 over 2 slope, I need to flip it. That's the reciprocal. So now that's going to equal 2 over 3. I just flip my fraction, and then it's always going to be the negative of that. So negative 2 over 3. Okay? What happens if my slope is already negative? Negative 4 over 3. Okay? Well, then my negative of a negative, when you have a negative of a negative, it's going to be positive, and my reciprocal is just flipping the fraction. So those would be perpendicular lines. If this one, m equals negative 4/3, and in this one, m equals positive 3/4, that would be the negative reciprocal. Okay? Again, I know there was a ton in that lesson, but this is all review. This is stuff that you learned last year. So if you are needing any more help, you can always rewind the video, watch it again, and just try to catch up if you are lacking in any of those areas. If not, go ahead and just try to practice some of these problems and do your best on them. So I hope you understood everything. If not, just go back and try to watch it again and try to figure it out. Okay? All right. We'll see you later. Bye-bye.